Electronic design automation is a category of software tools for designing electronic systems such as printed circuit boards and integrated circuits. The tools work together in a design flow that chip designers use to design and analyze entire semiconductor chips. This article describes EDA specifically with respect to integrated circuits. History: early days, before EDA, integrated circuits were designed by hand, and manually laid out. Some advanced shops used geometric software to generate the tapes for the Gerber photoplotter, but even those copied digital recordings of mechanically drawn components. The process was fundamentally graphic, with the translation from electronics to graphics done manually. The best-known company from this era was Calma, whose GDSII format survives. By the mid-1970s, developers started to automate the design along with the drafting. The first placement and routing tools were developed. The proceedings of the Design Automation Conference cover much of this era. The next era began about the time of the publication of Introduction to VLSI Systems by Carver Mead and Lynn Conway in 1980. This groundbreaking text advocated chip design with programming languages that compiled to silicon. The immediate result was a considerable increase in the complexity of the chips that could be designed, with improved access to design verification tools that used logic simulation. Often the chips were easier to lay out and more likely to function correctly, since their designs could be simulated more thoroughly prior to construction. Although the languages and tools have evolved, this general approach of specifying the desired behavior in a textual programming language and letting the tools derive the detailed physical design remains the basis of digital IC design today. The earliest EDA tools were produced academically. One of the most famous was the Berkeley VLSI Tools Tarball, a set of Unix utilities used to design early VLSI systems. Still widely used as the Espresso heuristic logic minimizer and magic. Another crucial development was the formation of MOSIS, a consortium of universities and fabricators that developed an inexpensive way to train student chip designers by producing real integrated circuits. The basic concept was to use reliable, low-cost, relatively low-technology IC processes, and pack a large number of projects per wafer, with just a few copies of each project's chips. Cooperating fabricators either donated the processed wafers, or sold them at cost, seeing the program as helpful to their own long-term growth. Birth of commercial EDA: 1981 marks the beginning of EDA as an industry. For many years, the larger electronic companies, such as Hewlett-Packard, Tektronix, and Intel, had pursued EDA internally. In 1981, managers and developers spun out of these companies to concentrate on EDA as a business. Daisy Systems, Mentor Graphics, and Valid Logic Systems were all founded around this time, and collectively referred to as DMV. Within a few years there were many companies specializing in the EDA, each with a slightly different emphasis. The first trade show for EDA was held at the Design Automation Conference in 1984. In 1981, the U.S. Department of Defense began funding of VHDL as a hardware description language. In 1986, Verilog, another popular high-level design language, was first introduced as a hardware description language by Gateway Design Automation. Simulators quickly followed these introductions, permitting direct simulation of chip designs, executable specifications. In a few more years, back-ends were developed to perform logic synthesis. Current status: current digital flows are extremely modular. The front-ends produce standardized design descriptions that compile into invocations of cells, without regard to the cell technology. Cells implement logic or other electronic functions using a particular integrated circuit technology. Fabricators generally provide libraries of components for their production processes, with simulation models that fit standard simulation tools. Analog EDA tools are far less modular, since many more functions are required. They interact more strongly, and the components are less ideal. EDA for electronics has rapidly increased in importance with the continuous scaling of semiconductor technology. Some users are foundry operators, who operate the semiconductor fabrication facilities, or fabs, and design service companies who use EDA software to evaluate an incoming design for manufacturing readiness. EDA tools are also used for programming design functionality into FPGAs. Software focuses, design. High-level synthesis for digital chips, logic synthesis, translation of abstract, logical language such as Verilog or VHDL into a discrete netlist of logic gates, schematic capture for standard cell digital, analog, RF light capture CIS in ECAD by Cadence and ISIS in Proteus, layout, usually schematic-driven layout, like layout in ECAD by Cadence, Aries in Proteus, simulation. Transistor simulation, a low-level transistor simulation of a schematic layout's behavior, accurate at device level. Logic simulation, a digital simulation of an RTL or gate netlist's digital behavior, accurate at Boolean level. Behavioral simulation, a high-level simulation of a design's architectural operation, accurate at cycle level or interface level. Hardware emulation, a use of special-purpose hardware to emulate the logic of a proposed design. Can sometimes be plugged into a system in place of a yet-to-be-built chip. This is called in-circuit emulation. Technology CAD simulate and analyze the underlying process technology. Electrical properties of devices are derived directly from device physics. Electromagnetic field solvers, or just field solvers, solve Maxwell's equations directly for cases of interest in IC and PCB design. They are known for being slower but more accurate than the layout extraction above. Analysis and verification, functional verification, clock domain crossing verification, similar to linting, but these checks tools specialize in detecting and reporting potential issues like data loss, meter stability due to use of multiple clock domains in the design. Formal verification, also model checking, attempts to prove, by mathematical methods, that the system has certain desired properties, and that certain undesired effects cannot occur. Equivalence checking, algorithmic comparison between a chip's RTL description and synthesized gate netlist, to ensure functional equivalence at the logical level. Static timing analysis, analysis of the timing of a circuit in an input-independent manner, hence finding a worst-case over all possible inputs. Physical verification, PV, checking if a design is physically manufacturable, and that the resulting chips will not have any function preventing physical defects, and will meet original specifications. Manufacturing preparation, mask data preparation, MDP, generation of actual lithography photomask used to physically manufacture the chip. Resolution enhancement techniques, or ETA methods of increasing of quality of final photomask. Optical proximity correction, OPC, a upfront compensation for diffraction and interference effects occurring later when chip is manufactured using this mask. Mask generation, a generation of flat mask image from hierarchical design. Automatic test pattern generation, ATPG, a generates pattern data to systematically exercise as many logic gates, and other components, as possible. Built-in self-test, or BIST, a installs self-contained test controllers to automatically test a logic structure in the design. Companies. Top companies, market capitalization and company name as of DEC, 2011, $5.77 billion a Synops, $4.46 billion a Cadence, $2.33 billion a Mentor Graphics, $489 million a Magma Design Automation. Synops acquired Magma in February 2012, $6.44 billion new Taiwan dollars a Springsoft. Synops acquired Springsoft in August 2012, a 11.95 billion yen a Zuken Incorporated. Note, ESF should likely be on this list, but it does not have a market cap as it is the EDA division of Agilent. Acquisitions. Many of the EDA companies acquire small companies with software or other technology that can be adapted to their core business. Most of the market leaders are amalgamations of many smaller companies. This trend is helped by the tendency of software companies to design tools as accessories that fit naturally into a larger vendor's suite of programs on digital circuitry. Many new tools incorporate analog design and mixed systems. This is happening because there is now a trend to place entire electronic systems on a single chip. Table of quarterly EDA industry worldwide revenue, see also. Computer-aided design, circuit design, EDA database, SIGNOF, comparison of EDA software, platform-based design, references. Notes